Hey YouTube. In today's video, we are going to explore NixOS generators, a powerful tool that lets you generate various image types for virtual machines or for cloud providers from a single NixOS configuration. So whether you need images for your AWS cloud, for Linode, or for your local hypervisor, NixOS generators has you covered. In this video, we will cover what NixOS generators is and why you want to use it, how to set up a basic configuration for image generation, and we will be creating a couple of images just to test things out here. And of course, I will give you some practical tips and some pitfalls to avoid to make things a little bit easier. By the end of this video, you will understand how you can build reproducible system images for various platforms using a single NixOS configuration. So let's dive into it. NixOS Generators is a community project, and of course you will find it on GitHub. I will link to NixOS Generators in the description below, and I will also link all the code that I built here within this video in the description. Here I have a very basic NixOS configuration. In this case, this is a very simplified desktop system with the KDE Plasma 6 installation. And we are not doing very much here. We have a very basic NixOS configuration here, and we have a system named M3 Zelda. And we import the configuration.nix module here. And when we have a look into the configuration.nix, we have a grub bootloader configuration here, a user setup, and some other smaller things. And just to have it differing from the default ISO, I will just install Brave and VLC for playing videos. And what NixOS generators will allow us to do is to create different images for different hypervisors or cloud providers just from this single configuration here. Actually, when you have a Nix-enabled system here, you can just go to your terminal, and then you can just use the nix run command to run NixOS generators without even installing it. So in this case, we execute NixOS generators, and then we give it a -- format. And then we select QCOW that I can use on my Word Manager installation on this machine here. And we refer to the flake and the system configuration that is named M3 Zelda. And now I can just execute this, and this will create the virtual machine image for me. And as you can see, the image has been written to the Nix store, and in order to make it possible for Word Manager to interact with the image, I need to put it into a writable location because Word Manager will not be able to write on the Nix store. So I will just quickly copy that over to my folder here. And then I will just head over to Word Manager and create a new machine. And then I can just say import existing image. And I will just quickly get back to my editor and copy the path here. And now I can just provide the path to the image. And for the OS type, I just take NixOS unknown in this case, give it a bunch of CPUs. And then I can just start my virtual machine here. And as you can see, we have a login manager here that is configured in my NixOS configuration. And when I enter the password I have configured, I get into my NixOS desktop machine here. And as you can see here, I have Brave installed. And I also have the VLC media player installed. And as you can see, that was easy enough. I just generated a virtual machine just from one command, and I used an existing NixOS configuration. And for now, I won't need this machine anymore, so I will just delete it. And then I head back to my editor, And we just try another format. Now let's make another variant. In this case, I will just choose the format ISO. And I could use this to put this on a USB flash drive to have a live system I could just boot to. And when I execute this, you can see that I get an error here. And as you can see down here, the error message is telling us the option bootloader grub.enable has conflicting definition values. And then you can see we got two different sources for the value. First of all, we have the value coming from the CD/DVD ISO image.nix, and here it is false. And in my own configuration, as I have used grub in the configuration before, this is true. And this is why Nix will throw an error here. And in order to resolve this, I can just quickly go to my configuration.nix here and go to my bootloader section, comment it out, and then I can just rerun the command to get my ISO done. And as you can see, the ISO has been generated. And this runs pretty fast on my machine because I've tried it before, and most of the derivations are already in my Nix store. If you do it the first time, it may take a couple of minutes. And now I just copy the store path here to the ISO file, and I head back to my Word Manager. And here I can just, to show it, select the local media install from ISO image, and I hit forward, and I just point to the image here and select NixOS once more and give it a bunch of CPUs. And in this case, I don't want to enable storage for this virtual machine. And then I can just start the machine, and you can see we get a bootloader that will hold one single configuration, and that is the one that is configured in our configuration.nix. And now it will just boot into the system. And as you can see, we have the exact same result. So I can just log in with my defined credentials here. And now KDE is starting. And as you can see, Brave is installed from our configuration, and VLC is also installed. And that is just the tip of the iceberg. So when we head to the NixOS generators Git repo, you can see there are a lot of formats that are supported. For example, just to mention a few, we have Amazon for Amazon EC2 images, we have Azure, we have CloudStack, we have Docker, we have Google Cloud. We have things like Proxmox, VirtualBox, VMware, and so on and so forth. So there are a lot of different images you could just generate from one configuration. Of course, it is not that easy, really, because all the different formats, they come with different requirements. So when we head back to our error, in this case, this was a very simple error, and we could just read from the error message what the problem was. But on some scenarios, you have more complex errors, and you will need to find a way to understand how these errors happen here. And just from my experience with NixOS generators, most of the errors that you will encounter are coming from hardware configuration and file systems, really. Because the various virtual machine types and cloud provider images, they have slightly different requirements when it comes to bootloaders, when it comes to hard disk configuration, and so on and so forth. Actually, the most of these problems are pretty much resolved just by reading a little bit into the code. So on the NixOS generators repo, you have a formats folder. And in here, you have all the format definitions. So for example, let's have a look at the QCOW format here. You can see the file system is already defined in the format module that comes with NixOS generators. So that means for us, we don't really need to configure a file system in our system configuration. And the same goes for boot configuration and grub configuration in this example here. And when I head back to my code here and have a look into my hardware configuration, you can see that there are a lot of similarities. So for example, we import the guest tools here. And when I have a look at the repo, this is also what is done by default from NixOS generators. And as long as there are no conflicting values in your own configuration compared to the formats in NixOS generators, everything will be fine and you will not encounter any errors. But if you encounter conflicts or errors, this is the first place I would look and see how this is built and what these modules are using and expecting. And then it's usually pretty easy to resolve conflicts here. Now let's have a look at another format here. For example, we have the Proxmox format here. And here you can see this module is quite short. And the reason why it is so short is it imports the proxmox-image.nix from Nix packages. If I want to know what is defined here and what the values default to, I need to find this module on Nix packages. So here I can just head over to Nix packages and just search on the repo for the folder and the file name. And you can see here I have the file that is referenced by NixOS generators. And down here I have all the configuration I need. And when I scroll down in this file, and this is a little bit more complicated than the other one, I still find, for example, my default values for the file system definitions here. And here I have the grub bootloader configuration. So this would also allow me to debug any conflicting values here pretty easily. Another way to use NixOS generators is to use it directly in our system configuration. For this, we will just need to add another input here to our flag. And here we refer to NixOS generators on GitHub and define that it should follow the version of Nix packages. And of course, we will need to add it to our outputs here. And then we can just add the NixOS generate configuration alongside our NixOS configuration. So here we have packages, and then I have my system type here. And then I have one definition for ISO and one for QCOW in this example here. And this will use the NixOS generate function that is provided by the input we have defined up here. And as you can see, we do the same as we do up here in the system configuration. So I just pass configuration.nix to modules here. And now I got my system configuration up here, and I got two defined image configurations. And when I want to build, for example, the ISO format, I will just open my terminal and I will just say nix build. And then I refer to the name ISO in my flake here. And now it will start building my ISO image here. And now my ISO has been built, and I have a result folder here that points to my Nix store. And within the result folder, I have an ISO folder. And when I have a look into the ISO folder, you can see I got my ISO file here, and I could use it just as the one I did before. And of course, I could just do that also for the QCOW configuration here. So as you can see, the structure is very simple. We have a name here that we assign the result of the NixOS generate functions to. And the NixOS generate function gets a system attribute, so it knows what architecture to build for. And then we have the modules here, and then we just define the format here. And the format you can just get from the list here on the NixOS generators repo. So for now, this is a pretty easy setup here. And let's try and make it a little bit more complicated when it comes to hardware configuration here. So I will just delete my result folder here. And let's pretend we use disko for partitioning and creating our file systems here. So I will just add disko to my inputs here and make the inputs available and refer to the disko input here in my modules. And of course, I will need a disko config here. So I'll just create a disko config.nix and paste in my device configuration here. And in this case, this is a GPT table that refers to the device /dev/SDA. And we have a boot partition and a root partition, and that's it so far. And in our configuration.nix, we would of course need to import our disko config here. And now I will just add the new file here to my Git repo. And I will just do a quick Nix flag check here. And as you can see, as of right now, I get a couple of errors here. And you can see it is complaining that disko does not exist on our NixOS generators configurations. And that's of course because I didn't add it here. And usually you don't want to mess around too much in your configuration. So the idea here is that you have an existing configuration and you kind of reuse it. And for this, we will need to create a way that we don't need to modify our base configuration. And we can do that easily just by using a little bit of Nix functions here. So for example, we could just create a conditional import here on our configuration.nix. And the way we can do that, we can make lib available so we have access to library functions here. And then we could just use the lib optionals function here to check for an argument that is called isImageTarget. And of course, we will need to add this to our function arguments up here. And now we head back to our flake.nix. And we need to make sure that we pass in the argument here. So for my regular NixOS configuration, I will of course say isImageTarget false. And that means in this case, when it's false, that my configuration.nix will import the hardware configuration and the disko config.nix. So I can easily build my regular system configuration. And when I head to my NixOS generate parts here, I can just say, okay, this is true. And I will also copy this down here. And now we have got a nice and easy way to handle the different scenarios when it comes to partitioning and the file system configuration. And now I will just check my flag again. And as you can see, the Nix flag check succeeded. And I can easily build my system configuration, or just to have another example, I could just say Nix build, and then let's say we create the QCOW image here. And this is of course just one simple example and just one approach. There are many ways to make this flexible and conditional. And with this, you can really make sure that your system configuration stays untouched. So you can build a dedicated system for it, and you can easily just make a variation within the same configuration where you define the parts that you need for certain image types. And as you can see, this is built now, and I got my results folder up here. And when I look into the results folder, I got my image here, and now I could use it in my Word Manager installation on my local machine here. As we have seen here, NixOS generators is a powerful tool to create various images out of the same NixOS configuration. And while I've focused more on local VMs today, NixOS generators also supports generating images for popular cloud providers like AWS, DigitalOcean, or Google Cloud and Linode. But you have to keep in mind that each of the target platforms might have their own requirements when it comes to the details in the configuration. And therefore, the way I have showed you to have a look into the formats on the NixOS generators repo is a great way to find out what you will exactly need to make a variant of your NixOS configuration that will work for the image type you are targeting. The real power for NixOS generators comes when you integrate it in your development workflow. For example, you could automate the image building process and also take it a step further to deploy the images to your favorite cloud provider to use them there. So that was a short overview on how to use NixOS generators. If you like content like this, please feel free to like and subscribe. And I see you in the next video. Have a nice time. Bye bye.